Let's find the maximum minimum of f of xyz equals xyz with our constraint being x squared plus 2y squared plus 3z squared equals 6. For this, we're going to use Lagrange multipliers. So we want the gradient of f to equal lambda times the gradient of g. So we'll list out all the partials. And now we take the derivative. So the derivative of f with respect to x is yz. That's going to equal to 2x lambda. And then f with respect to y is xz, and that's going to equal 4y lambda. And then f with respect to z is xy, and that's going to equal 6z lambda. And so we want this to satisfy the constraint. So let's first notice that xyz is going to be positive if all of them are positive or if only two are negative. So that'll be a maximum, which means 0 is not a maximum. And then it's going to be a minimum if all three are negative or one of them are negative. And so that's going to be a minimum, which means that xyz cannot equal 0, and that says that none of them could equal 0. So x, y, and z cannot equal 0, because that will not give us a maximum or minimum. So let's keep that in mind as we're solving this. And the way to do this, a good way to do this is actually to divide these equations, because I don't care if they're 0. So they're not going to be 0, so that means I could divide. So let's take the first divided by the second. We have yz over xz equals 2x lambda divided by 4y lambda. That gives us y over x equals x over 2y. Cross multiply, 2y squared equals x squared. So x is equal to plus or minus root 2 times y. Now let's take 2 divided by 3. We have xz divided by xy equals 4y lambda divided by 6z lambda. Z over y is equal to 2y over 3z, which I can cross multiply again and get 3z squared equals 2y squared. And I can solve for z. And the reason I'm solving for z is because here I want it in terms of y. So solve in terms of y. So this will be z squared equals 2/3 y squared. And then taking the square root of both sides, I have z is plus or minus root 2 over 3y. So x is in terms of y, z is in terms of y, and obviously y is just y. So then I can plug it into my constraint, which we said was x squared plus 2y squared plus 3z squared equals 6. And so that's plus or minus root 2 times y squared plus 2 times, or 2y squared. And then z is just plus or minus root 2 over 3y. So that's 2y squared plus 2y squared plus 3, and then this is 2/3 y squared equals 6. So it's 4y squared plus 2y squared equals 6. 6y squared equals 6, and so y squared is 1, which means y is plus or minus 1. Now from here we can solve for x, y, and z, or x and z rather. X will just be plus or minus root 2 times plus or minus 1. Y is just plus or minus 1, and then z is plus or minus root 2 over 3. So from here we get 8 different points. I will not list them out, but basically, you want when all of them are positive, one of them is negative, and then 2 of them are negative, and then when they're all negative. Okay, so when you do that, you plug it in back into f of xyz equals xyz, and the maximum will be 2 over root 3, which is just 2 root 3 over 3. And then the minimum will just be the negative of that. And so this will be the final answer.